Welcome to the Impulse Spotlight, a podcast for product development professionals. In this episode, we speak with the founder of WJ Titan, an ISO accredited inspection lab founded strictly on the inspection needs within manufacturing. He was born and raised in Fort Wayne, Indiana, and graduated from the then called IPFW in Fort Wayne with a marketing degree. When he's not taking micron level measurements, he enjoys golfing and spending time with his wife Emily and their 3 children. Jim Rorick began his career in the calibration and inspection industry with little prior knowledge, but quickly realized it was the perfect fit for his skills and passion. After gaining professional experience and navigating a couple of acquisitions, he and a partner decided to take the leap and started WJ Titan, which has become a trusted name helping manufacturers across various industries ensure their parts and specialty gauges are correctly made. In today's discussion, we discuss the multitude of tools in Jim's inspection lab used to take highly accurate and detailed measurements. We talk about communicating with clients, understanding their requirements, and finding a healthy balance between working fast and performing good, precise work. We learn how each part comes with its own unique challenges and get a strong understanding of how a part moves through the quality assurance process. Join us as we develop a new understanding of an often overlooked process and gain some sympathy for the teams of people working hard to help us hit our deadlines. Let's get into it. Hey, Jim, welcome to the show.
Hey, thanks for having me, Troy. Appreciate it.
Yeah. So I started Impulse a little over 25 years ago, kind of saw the writing on the wall that the company I was working for that had all facets of product development under one roof. Saw the writing on the wall. They were not going to be around much longer, so I started Impulse, and we help people design products. How did you get your company started?
Geez, so it's kind of a weird, long story. It's kind of accidentally getting in the industry. So 20 years ago, I was in just like random sales positions, like copier sales, things like that. Didn't really think it was for me. And so I was at a crossroads, and I stumbled upon a couple guys who owned a calibration and inspection lab, and they needed a sales guy, and I went and worked for them, and I had no industry knowledge at all about calibration or part inspection or any of that kind of stuff. So yeah, 20 years ago, started there working for them, and through some acquisitions and other companies getting bought and buying, like they sold their company, got under a big company, was part of starting another smaller company, another inspection lab. It got bought by a big company also. And then through all of that, I've always just kind of felt a need to not really work for someone else. I have, my wife would tell you that I don't like listening to people and I don't like being told what to do. So I thought I had better ideas. And so it's been like for WJ Titan, we started it about 8 years ago, me and a business partner. One of the brothers from that original company, we kind of came back together and said there's still a need for this. And so yeah, about 8 years ago, we started WJ Titan, and here we are.
Cool. And what services does WJ Titan provide?
Yeah, sure. So we're a ISO 17025 accredited inspection lab. So we help customers with really any kind of part inspection. So people will send us medical implants or automotive parts or engine parts for tanks or just a whole array of different types of parts. And then we tell them dimensionally whether or not they're good or bad. And we tell customers a lot that we don't care if they're good or bad, and you don't want me to.
Right.
So they'll come to us for like as an independent third party. So maybe company A made parts for company B, and company B says they're no good, and company A says they're good. They'll send them to us as just an independent expert, and then whatever we tell them kind of goes. Or the majority of our customers have a lab like ours in-house, and they're just so busy. Like it's hard to find people who are really good at this. So maybe they don't have the bandwidth to do it themselves. So they'll contact us, and we'll help them get parts inspected faster, either PPAP parts usually or FAL parts, first articles, things like that, so that they can ship parts.
Interesting. Do you literally, that's what you do? You like, they send you parts, you measure parts, say they're within spec or out of spec, or are there other ancillary services that you guys offer as well?
Yeah, so that is the core of what we do. Um, we have a 3D lab that we do very small volume of 3D printing.
Okay.
We've done a couple prototype projects for customers that we already did other work for. Nothing crazy, nothing special. The majority of what we use that for is 3D printing fixturing. So we'll get some very convoluted parts or have very interesting shapes to them and surfaces that are really hard to hold just with like a vise or a clamp or something like that. So we'll 3D print a fixture that maybe has a curvature that matches the bottom of a part, so it'll fit flat. Because if we're measuring parts down to, you know, accuracies of in the microns or tens of microns, any kind of movement when we touch it can throw that data wonky, right? And at the end of the day, the only product we have are numbers on a piece of paper, right? So
Yeah. Yeah.
it's a little frustrating at times that that's what we're like, here's what we have. But we have to make sure that that data that we hand over to customer A is the best data it can be. So we'll do 3D printed fixturing. We do a lot of that. Other than that, I've always wanted this company to stand alone as the expert in inspection. So we do part inspection and we do specialty gauge inspection also. So
Okay.
it's the same type of thing. It's still linear dimensions on a chunk of metal or plastic. It's just the gauges somebody would pass or fail their parts with. So it's not calibration per se, it's inspection. And we've always wanted those to be the course. People are always like, oh, can you make gauges? Can you design gauges for us? Can you do reverse engineering? Can you do these things? And I've always just felt like it was important to have a company that just specialized in a niche service that didn't have a ton of competition. And stand alone, because if I start making gauges for somebody or design gauges, now I'm competing with other customers that I have who make gauges. And so always wanted to be like a silo that just did this.
Sure.
To be honest, I feel like it kind of held some credibility for us, and kind of made sure that we were. So like, I never wanted to be, if we're inspecting gauges for a company and we fail one, right? I don't want that to ever be thought of as, oh, they failed it, so they can make us a new one and sell us a new one.
Right. Sure.
Is that probably overthinking it a little bit? Probably. I mean, to be honest, probably. But I've never, a lot of times people don't have to use us, right? They
Mhm.
could, a company who has an internal lab could choose to bill 10 hours of overtime to finish this project. Instead,
Right.
they trust us and they say, hey, we know you're doing it the right way. We know you're doing it right. Instead of keeping it in-house, we're going to send it to you for speed and accuracy, and we know what we're going to get. So I never really wanted that, like a gray area. So, gauges, parts, mostly just linear inspections and some 3D printing.
Okay.
Yeah.
Is there, so in my little knowledge of inspection, is it all linear, or are there other types of inspection that you could be doing?
Yeah. So what we do, we call it linear, right? And it's more than just a length from this point to that point.
Okay.
We get into some very specific GD&T callouts, right?
Okay.
So if there's people watching this who don't understand that, that's geometrical dimensioning and tolerancing. And so we get into surface profiles and lines of profiles and runouts and total runouts. All of those things are under the umbrella of linear dimensions, but
Okay.
they can get very complicated and a little ridiculous at times, to be honest.
Sure. So it's
So,
not just, hey, what's the distance from a hole to a hole, or what's the diameter
right,
of a hole? It can be way more complicated than that.
right. More than that, it's position of holes, profiles of surfaces,
Hmm.
positions and profiles. We see a lot.
Okay.
and then, hole size and things like that just go with any, all kinds of parts have holes. So, yeah.
Cool. Tell us about your team. What are what kind of team do you have, and what are their
Oh,
different
yeah.
roles?
Oh, we have a great team. That's something I'm super fortunate to have. There aren't a lot of really skilled people who can run CMMs and can run vision systems and can understand GD&T at the level my guys do. We have a small team. There's 5 of them here who work for us now. I've been up to, I think, 7 or 8, and I think this is about the smallest team we've had, but it's the best team we've had. And so I have a lab manager who is ridiculously versed in how to do this. He's super talented. I'm super fortunate to have him. Being a small company, it's hard to compete with big companies who splash 401k matches and great insurance and all of these benefits that, is a real struggle for small companies in 2024, right? Like insurance is expensive and all that stuff costs money. And so we're really fortunate to have the team we have. So we have a lab manager, Ryan Plew. If you watch go to our YouTube page or our LinkedIn page, we have in the lab videos, so you can see him on there giving videos about surface profile versus line profile and just all kinds of issues that we have customers ask us questions about. So we have him, and then we have 2 CMM programmers below him. They're great. They're a couple young guys who, it's very rare to find young guys in this. And then we have a vision division. I have one guy we have 2 vision systems, OGP vision systems that are really accurate. And so he does all of that. And then I have a guy who is, I don't know how to explain what he does. The crux of his job is to make sure our reports are right. Because like we said, our reports are our product, right? And there was a point where we were doing a very big project for a medical device company, and our reports were 80% wrong. Like there'd be something wrong with 80% of them. And so he's actually a really good friend of mine. We've been friends since we were 16, and you can tell that I'm much older than 16. And so we've been friends for a long time, and he's very detail oriented. He's great. And so every report goes through him. He makes sure he goes through them with a fine tooth comb, makes sure that they're right. Gives them back to the guys. They give them back to him. We have a big process, and we're down under 5% having issues. Just making that, So he was a great investment. So that's our team. Like I said, it's small, but they're mighty, as they say.
Yeah,
and,
that's awesome. I think a lot of companies, especially big companies, underestimate what just a few people can get done. We're real small too, but we can crank out so much work that. So you mentioned, I meant to ask this earlier, but you mentioned CMM and vision systems, and can you share a little bit about how those things work and what they are and how they enable you to measure and validate parts?
Yeah, sure. So we have 5 CMMs here and 2 vision systems. So a CMM is a coordinate measuring machine. It uses a probe with an actual ruby on the end of it, a ruby ball that's milled out of an actual ruby, which is very weird. And so it's touch inspection. So we program the CMM in an XYZ coordinate system, like we used to learn with I'm at the age where they taught us in school with the little triangle, like go-tos and all that kind of stuff. And so it's like half computer programming, half math. Mm-hmm. And so the machines go around and they touch the part and measure it in their 3D system, XYZ coordinates. And that's contact inspection. And then our vision systems are non-contact inspection. They have probes and lasers on them, but we don't use them because we have so many CMMs, right? And I tell people it's wrong. There's going to be people who are vision gurus who say what he's saying is not true. I look at it as a microscope. It's not a microscope, I understand, but they can zoom in. I think our most accurate one goes to like 400 times zoom, accurate under a micron, very accurate, can zoom in to see things you don't want to see. Like we show customers, hey, it looks like this. And they'll be like, can you zoom out a little bit so we don't see all that chatter? And then can we measure the circle?
Wow.
Sure, it's your circle, right?
Yeah.
So
Interesting.
we have two of those, and we use those for more accurate things, smaller parts. As you know, I'm sure you've seen a lot of medical device parts and whatnot that have like super small etching on them, and
Mm-hmm.
all that stuff is called out on prints. So we're measuring depths and heights and widths of letters and numbers with that, and we zoom in to where it looks like the whole screen. And so they're very powerful. They do a lot. And we have 5 CMMs. Our biggest CMM is 10 foot by 6 foot by 6 foot measuring envelope.
Oh, wow.
Yeah. So less accurate because it's so big, but
Sure.
we have all machines all the way that big down to a vision system that is accurate just under a micron. So
Wow.
we have the whole array.
Awesome. When you get
Yeah.
a part that big, do you have cranes and stuff to bring it in and lift it in, or how does that work?
So that the big CMM's in a different area of the lab, right? It's its own little area, and so we have a forklift back there that's
Okay.
4,000-pound forklift.
Okay.
And so it handles it usually. There's been a couple times where we've had to rent like an 8,000-pound forklift,
Right. Wow.
but that's big hunks of steel.
Yeah,
It's
that's pretty
big
cool.
hunks of steel.
Yeah.
I think regularly we get 600-pound part like castings or 1,000-pound
Sure.
castings, and
Yeah.
we just move those around like they're nothing.
Yeah.
But yeah, we've had a couple times where we've had to get some big boys.
Cool. So also, you mentioned the ruby. Why do they use ruby? Is it a hardness thing? Is it they're able to machine it to a certain accuracy? What's the reason for a ruby?
That's a great question. I have no idea. I have no
Okay.
idea. We have them, we get them down to 0.3 millimeter diameter on.
Wow.
We get them that small to get into nooks and crannies, and they have 6 millimeter ones, and 10. They have just a whole array. Geez, easy for me to say. Cylinder probes, just all kinds, and it's very interesting. And I have no idea. They make so many of them. There's so many out there. It's like the 0.3s. They look. You would think is a toothpick. Like you can't even see the ruby. Really, it's 0.3 millimeter diameter.
Yeah.
So
That's
small.
interesting.
Yeah.
Very. So, in kind of your little neck of the product development world, what do you see the biggest challenges that product development professionals struggle with?
Oh, so on our side, and I think my guys would tell you for sure, it's understanding GD&T,
Okay.
understanding. Like I think it's, and this is just from my very limited knowledge, right? From an outsider's view. I think the easiest part is envisioning what kind of part you want to have,
Mhm.
right? You want to design a knee that fits this size person. Okay, how's that work? And so this is what the knee looks like. Trying to design a knee or a hip or a screwdriver or anything, and having the manufacturing process in your thoughts of how are we going to make this, and how are we
Mhm.
going to hold these tolerances, and how are we, I've seen surface profiles on injection molding surfaces that are a millimeter by a millimeter with a 0.4 surface profile tolerance on them,
Wow.
right? 0.4 millimeters. Like from the inspection side, I want to be 4 times as accurate as what I'm measuring, right? So that I know I'm more accurate, that I'm getting good data.
Yeah.
4 times tighter than 0.4 is 0.1 millimeter. Like you're getting down in some crazy things, and
Yeah.
you get down in the microns and 10 microns. I got to be 4 times better than that. So, from my limited view, I think it's designing with manufacturing in mind. And the worst part for us is they never have inspection in mind, right?
Sure.
I don't think there's ever a conversation of how are people going to inspect these so we know they're good,
Yeah.
right? Like I think that's they can figure it out. Right? They can figure it out deal. And so we get stuck sometimes at the end figuring it out, which we do a really good job of being creative, especially with the 3D printing. Like I said, we get really creative with fixturing, and we have all the tools to be able to do things. But man, sometimes it's tough.
Yeah, I can imagine. Do you think it's ignorance on maybe a little bit of ignorance on their part? They're like, oh yeah, we want the plus or minus 0.4 millimeters, because they don't understand like what that really takes, or is it really they need that? And you're like, wow, this, I don't know why they need this, but this is crazy.
Sure. I think it's I just think, look, you have a designer or you have an engineer or whoever who goes to college to learn how to design and engineer parts.
Mm-hmm.
I don't think they ever learn how to inspect parts, right?
Yeah.
And they probably don't learn a lot about what kind of manufacturing is going to be entailed in this and what those processes look like.
Yeah.
And then they get into the workforce and they're thrown into, it's time to start designing. Like, let's get to work on designing. And,
Yeah.
I don't know. I don't think there's a great understanding of the entire process from day one design to implementation and use in the field, right? Yeah. No matter what the product is, whether it's a set of rims on a car or it's a spark plug or it's a lug nut, whatever it is, right? There's so much emphasis on how it looks, which I get, right? But I don't feel like, from an outsider's view, I don't think there's enough emphasis on how it's made, how we're going to make it, who can make it this good. Are there machines that can machine it this good? What's it cost to machine something to this level, right?
Sure.
And then, okay, we found somebody machine it. Who in the world's going to inspect it, right? And how do we know it's good?
Yeah.
And so, just again, from an outsider's view, that's what I think is probably the biggest thing we see. I mean, we see these videos we do are a lot about interactions we have with customers who don't understand GD&T. And that's even in like a lab situation, in a quality lab situation, who don't understand it and are asking us to do something one way. And we're like, that's not exactly right. So I guess it's kind of passive aggressive that we make these videos about them, but it's to educate people. It's to help people understand more of how these things work and how we're inspecting parts. And at the end of the day, the fundamentals of inspection and the importance of it, because you want to know if these parts are good or not, right? Like, so yeah, that's what I kind of think.
Yeah.
Not that we're frustrated about it at all, right? Not that I get frustrated about it. Clearly, I do.
Yeah. Yeah, but it makes total sense. I mean, heck, when I was in school, I think we may have spent 2 weeks on GD&T and thinking about stuff like that. So, yeah, and GD&T is like, unless you are practicing that like you every day, it's a tough nut to do correctly. So,
yeah, and then we see parts that are legacy type parts that are old, that aren't. We've had handwritten prints with fractions on them for dimensions. Like, so GD&T fundamentals have changed since somebody hand wrote fractions on a print, right? Like, they change those things all the time. Unilateral profiling is one of those things that, just in the 20 years I've been involved in this, I've seen at least 3 iterations of how to draw unilateral tolerancing on profiles. And so people don't usually understand what they're looking at.
Yeah, that makes sense. Yeah. So a big thing in our part of the product development world is time to market. Like everything, it's like, how fast can we do this and get the product to market? When you're helping product development teams, I mean, is that a factor? And do you guys help time to market? If so, how? And
yeah, so we are always on the back end. We're the last ones, right, in that timeline. Which means, as the people in the middle of the timelines, time takes longer, our time gets shorter, right? So
Sure.
I run this lab as it's just like a job shop. It's first in, first out. Um, and one of the advantages we have is we have multiple machines. We have more machines than we have programmers, right? So we don't. Our turn times are faster than a lot of people's because even though we don't have a huge team, we have a good team, right? We have systems in place that people follow to cut down on time, to cut down on questions. And we also live by this mantra. I've always lived for the last 20 years. I may ask awkward conversations at the beginning to keep us from having really awkward conversations at the end of the process,
Sure.
right?
Yeah.
So, we get involved at, less than 5 times people have gotten us involved before it's PPAP or FAL time, right?
Yeah.
Hey, this is coming. We have this weird feature. Can you help us how we're going to draw this so that you can inspect it? 5, maybe less than 5 times.
Wow.
Usually it's, here you go.
Yeah.
Good luck. Here you go.
Said it's the 11th hour. So.
all for sure. We have a really good core customer base that doesn't treat us like that, but there's a lot of times I like it when customers say things like, man, I know we're asking a lot. We need this in this time frame. I appreciate they at least see that, but we're always like, it's the world we live in. I've over the 20 years, there's been multiple times where I've been in a Christmas party for work and gotten calls from customers, all like Christmas Eve. Hey, can you have these done by the 1st? Okay, sure, drop them off, right?
Yeah.
It's just a reputation that over the years, people I've worked with, the other companies I've worked for, it's just been ingrained in me. That's how we do it.
Sure.
It's a burden and a gift, I guess. That's how it's an expectation that we set, that we get things done quickly, but we get them done right. That's kind of the world we live in. And so we do ask a lot of questions up front, but it's to keep us from missing something or, and the worst thing is to be at the end of a 50-part inspection project and have missed something, right? And had to go back to 50 parts or, something in the field already. And so we try to cover everything at the beginning with, policies and procedures that we have.
Can you share a specific example of how somebody used your service and that it was a successful outcome?
Oh boy. So, we were we do a lot of work for a couple of major medical device companies, and I guess this is. We don't toot our own horn very much, but this is a good one. So one of the major ones came to us and said, hey, we have this huge project. It's the biggest project. It's 190 SKUs for implants, right? So the actual parts, FALs, and another 400 SKUs for instruments, right? So any instrument that will go into those surgeries. Can you do all these FALs in the next 6 months? No. Right? No. Right? So we're honest up front. No, we can't do that. So I said, just give us implants. Those are the most important. We'll knock all these implants out. And then if we have time, right, we'll chew up whatever else you can to hit your date. So we knocked out all the implants and we ended up doing half of the instruments that the competitor they had to go to couldn't even do. And so, in the same amount of period, got them, where they needed to go. We worked a lot of hours. We did a lot of stuff, for them. And, that it's just people would say, wow, they really went above and beyond. And it's just how we do it. It's just how it's ingrained in our team. And it's just the mentality we have to try. I don't ever want to be the reason that a project doesn't hit the market on time, right? I don't ever want somebody in an office that I'm not in a meeting that I'm not in, like, hey, what happened here? And somebody be able to say, oh, WJ Titan dropped the ball.
Right.
Right. And so that's just been part of our DNA here. Companies that I've been a part of before, it's just something that is ingrained in us and our team, and it's what makes us successful. That you know we, I mean, we had an automotive project where we were running 50 machine hours a day, 6 days a
Wow.
week for
Wow.
18 weeks. Yeah, yeah. I mean,
Wow.
it's a lot, right? It's like we have 5 CMMs, right? And so 50 machine hours a day. And then
Yeah.
so we had to balance, hey, we have other customers too, right? We can't
Yeah.
not do their work. So we were running 3 shifts. I think we ran 21 hours a day.
Wow.
Yeah. And they were on full containment, and it was killer. It was a killer project, but we did it, and we helped them find their issues and helped them. I mean, that's almost sorting on a CMM, which is a lot,
Yeah.
right? That's a
Yeah.
lot of work.
That's awesome. Did I know you won't be able to give me an exact time, but how long does it take to measure a part? I know that's going to be dependent on measurements and all that, but is it manually measured, and does each measurement have to be done by hand, etc.?
Yeah, that's a great question, and I get that question on almost every project. How
Sure.
long's how long's your normal turn time,
Yeah.
right? And I tell people all the time, I've had a 10-foot long by 6-foot piece on our big machine that
Hmm.
had 5 features on it.
Okay.
It only had 5 features. It took 2 hours. 2
Right.
hours, done, right? I've had a part this big that had
Hmm.
1,000 features on it.
Oh,
A
wow.
1,000 features. No exaggeration. It's probably less than was actually on it. That took 2 weeks,
Yeah.
right? Just for one part, just to program one part. So that is the advantage and the downfall of using CMMs is you are programming every feature,
Hmm.
right? Every feature they have. It's a person sitting at a computer, headphones on, nerding out, telling the Ruby where to go.
Okay.
It's good because every feature has that person's hands on it, right?
Hmm.
So they know the vectors they have going into it. They know that it's done right. Um, the downfall is you have time in every single feature. So,
Right.
you know, on average, I think a normal dimensional feature probably takes about 10 minutes to program by the
Okay.
time you're doing everything through it. So if you have 1,000 features, you have 10,000 minutes, right?
Right.
Like it's a long time.
Yeah.
And
Yeah.
then you have to run that program to make sure you're not shanking out, not mishitting, making sure you're
Yeah.
getting good data, making sure it repeats, right? Like we get into all of that kind of science of, gauge R&Rs and, does our data repeat, and is it good data? Are we hitting the right features? Are we hitting, that's where, programming the CAD files is huge, right? Like when our customers have CAD files, we can zoom in on surfaces and we're doing most of the programming on the computer. And
Okay.
then we tell it all, go get it, right?
Interesting.
That's a huge advantage over the old days where you didn't have CAD files and you're doing everything literally manually,
Yeah.
So,
Interesting.
um, it's almost, I mean, the whole time last 20 years for sure, we've been able to program the CAD files, but I can assure you there's a time before that they couldn't. And I mean, the first lab I worked for, we had a manual machine, right? We had a manual CMM where you didn't have a joystick. You grabbed it and you took it down
Hmm.
to hit it. Like it's a big micrometer at that point, right? It's a big
Sure.
micrometer that can go 4 foot by 1.5 feet. And it was very interesting to see, now, you go into full programming and CAD files, and, you have small probes and different size shafts on those probes and different lengths. And these guys can do all kinds of things. And it's really fascinating to watch. I can't do it. I don't program CMMs. I don't do any of the inspections. My
Mhm.
background is marketing and sales, so I leave that to my expert guys. And sometimes watching them go to work is just, it's like art and science, right? And that's the other thing. Everybody does it different.
Sure.
It's all about the ends, not the means. So people do it all different. And sometimes that's a difficult conversation with customers. Hey, we have a program. Can we just send you the program and you just run our program?
Mm.
So for me, that's a gray area because being a 1725 lab, when I push that data out, I'm saying that's the right data, right?
Mhm.
And we're saying we believe in that data. So I have a hard time sometimes saying, yeah, like I don't know who wrote your program, right? I don't know how great it is or how not great it is. So we'll use it as a barometer and like a roadmap and then write our own programs and make sure that it's to our standards. So that's a
Yeah.
long answer for probably much easier question. But yeah.
No, that was interesting. It kind of leads into another question. When we work with our clients, like we do everything we can to like adapt to their process. We don't have our own internal, this is the way things are going to work. We're going to do things the way you want to do it. But it sounds like it's kind of the opposite for you guys. It's not anything to do with your customers. It has to do with the output that you're delivering.
Yeah. So, um, you know, being a third party lab, it's really based on customer needs and wants, right? So generally that's here's a print and a CAD file, and here's the tolerancing that goes with these features. Those conversations always also morph into, hey, just open up those tolerances. Like, so it's ±1, make it ±2. That's fine. It's what the customer wants. Like, I don't care.
Right.
Like, I don't care what we're checking. I don't care what the tolerances are. We put on our reports, customer requested ±2 instead of ±1 for features 4, 5, and 6.
Okay.
So what we do, how it is though for us is we kind of hold our own flag, right? As we're really good at this. And
Mhm.
so there are times where we'll come up with data that doesn't really maybe mesh or match what a manufacturer, like a supplier, has done in house, right? So they'll check it in house, make sure they have good parts, and then send it to us to do like an FAL or a PPAP inspection on it. There's lots of times where our numbers aren't the same. So what we do there is we have meetings, hopefully on site if they're close, and we really say, hey, watch how we're inspecting this. Bring your programmer. Let's talk about it. Let's look at what our standards look like, our inspection standards, because it's important for me that our whole team is writing programs as close in the same standard as we can, so
Sure.
that we're getting the best data possible. And so there's been times we did a big project or part of that real big project were some parts that has super convoluted surface profile on very small surfaces. And we were getting
Okay.
different data than the supplier. And so we had them come over and we went through it. We spent a couple hours really diving into the program. And we ended up liking the way they were doing it better than the way we were doing it. And so we said, hey, it doesn't go against any rules of GD&T or any inspection rules. It's just another way for somebody to do it, art and science, right? So yeah, we're cool with that. And then so we program the way they did. And it's a way for us to, we build relationships like that. It could be very easy for somebody to have a lab like this and just say, hey, that's the way it is.
Mhm.
It's bad. It's bad. It's on you. Figure out how to make it better. But
Right.
like, that's not the kind of communication that we believe in. And I mean, there are times where we say, well, you did that wrong. Here's why. That's wrong to the standard, to how the rules of GD&T, that's not right.
Right.
Here's why. Let's look at this. And people are like, oh, okay, that makes sense. So it's all about, getting together and being open-minded and realizing, again, it's art and science, and it's all about the ends, not the means. And Troy can program one way and Jim can program another way. And as long as we end up with a good program that gives us repeatable data, then everybody's happy.
Yeah. Interesting. So if somebody wanted to work with you, what's the process look like, for them to come in the door and then get a project moving.
Yeah, it's super easy. I try to make it as easy as possible, right? So the lead up to the project is all different ways. It's Zoom calls these days, it's in-person meetings, it's just phone calls, it's whatever. When people want quotes from us, all they have to do is send us balloon prints. Not even balloon prints, just prints. They'll send us a print or a package of prints and say, this is a 100% inspection, or we only need these features checked, or we need this many parts. And then we quote it. And then if they say go, that's when we get into the meat of it. We start looking at what the features really are, what the datum structures look like, how easy they are to get to. Do they make sense? Do they follow 6 degrees of separation? Is it a 3-2-1 alignment? All those kind of things that could throw off data. Hopefully we'll get a CAD file at that point and we get parts and we go to town. We have a internal scheduling system that gets everything in and out. I mean, I hear about places giving 2, 4, 6 week turn times on small, easy projects. And I don't think in the last 5 years, anybody's waited longer than a week to get parts started. So it's kind of, we're moving through projects as fast as we can while giving the best data we can. And so, yeah, we try to make it as easy as possible to do business with us. Because again, people don't want to, right? Like there's not a lot of people saying, man, I really hope we can send these 100 parts out to a third party and it cost us $100,000 to get this project done. There's not a lot of people sitting around having those conversations, right? They're like, wow, how do we hit our dates? Can we do it in-house? No, we can't do it in-house. Great. Who can we use? And how fast can they get it done? Yeah. And then that's when we get involved.
Yeah, that's awesome. That's the same way we try to operate. What are some of the best practices that people should know about you? I mean, you kind of mentioned the GD&T and things like that, but for somebody that's looking to do this, like what are some big highlights of, hey, you need to work in this fashion to make things flow smooth?
Yeah, again, we try to make it super simple. CAD files and transfer files is usually the hardest part. Like we have people ship us parts all over the country. We've done parts from Costa Rica. Like we get parts. We have parts coming from Oregon this week. We have parts from everywhere, California, East Coast. So, the one thing that, and I think I've touched on a little bit, is communication is the most important thing when it comes to doing business with us, right? Like just being open about what is needed and when it's needed. The worst thing is when we schedule something and we get parts and they say, hey, you have 7 days to get this done. Just get it back to me in 7 days. And then that turns into 3 days on the second day, right? So like communication is the best. My wife would tell you I'm not an amazing communicator, but I do all of it here. We over communicate at times and we prepare customers for that. Hey, this is the first time you've done work with us. You might get annoyed by how much you hear from us, but it's for the greater good. It's for a real reason to why you're here doing business with us and why we get a lot of repeat business, why we get, it's something I'm really proud of and that we've seen happen in our business is, especially in medical device, they may tell their suppliers, hey, send your FALs to WJ Titan. And the first time they're like, who are these people? Like, what is happening? Why would we do that? Who's going to pay for it? That whole deal. And I tell people, like, look, I understand how you feel, but I promise you it's going to work out. And the majority of the time it works out. And then those suppliers say, hey, we have parts for this other medical supplier. Can you do FALs for us for them too? Right. So that's when I get proud of how good our team is and how well we do, from the programmers down to Ben making reports. And, we're getting things in timely. We're following the standards we've set for ourselves. And as a business owner, that's when I get the most proud, when I can tell these guys, hey, XYZ company who didn't want to use us because they were forced just called us about 2 other projects that aren't for that company. And so, it's all about communication and it's all about being open and it's about being honest. And sometimes you have to have tough conversations that, customers don't want to hear.
Sure.
and, of I don't like the way this is drawn. The way this is drawn, you're not going to get good parts. The way the way these datums are set up, it's not going to work for you.
Right.
Um, you know, and so again, that we focus on communication. It's annoying at times, I'm sure, but at the end of the story, it works out,
Right.
right?
Yep. Totally understand where you're coming from there.
Yeah,
As we
I'm
start,
sure it works for you too, right? I mean,
yeah,
for
yeah.
you,
If we don't bug our customers, which I hate doing, but if we don't bother them early, like you said, it's just going to create a mess later. So yeah, they're going to be a lot with a new client, especially where you're trying to learn how they do business and what they need, and yeah,
yeah.
it gets a little tedious up front. So
Yeah, it's true. I mean, we try to make it as simple as possible. We try to make it as streamlined as possible. We try to make it as easy as possible. But there's bumps in the road all the time.
yeah,
There's things that don't make sense sometimes. There's a process that, a new customer doesn't understand why. Right?
yeah,
Why do I have to do this? Why do I have to send you this? Well, so that I know what it is.
yeah,
So that I'm not walking around in the dark. I need a flashlight sometimes. Right? Yeah. It's all communication.
yeah, yeah. So as we start to wrap up, just a few more questions, kind of shift gears just a little bit. What's the biggest change you've seen in your business over the years?
Man, if I go back 20 years to now, from when I first started, that first day I walked in, man, it was October of '04. So my daughter was born a month later. My first kid was born a month later. That's the only reason I know how long I've always been in this business,
Yeah.
because it's just longer than my daughter's been around. Um, if I say from walking in that day and seeing how the inspection lab was, technology has come a long way. The way the softwares interact with CAD files and the way they interact with the machines, the whole, like the CMM to CAD file to programming, that whole process is much better. There are some, not to nerd out on this too much, but there are some heads for these CMMs that are just doing ridiculous things, to where if you with a probe, the ruby's on the end, then the probe, then the head, and they index in certain angles to be able to measure, right? And
Hmm.
so, but they only go at certain degrees traditionally, or they're
Right.
fixed even. And so we have one here that's infinite. So it goes down, and instead of the head moving, the probe just moves by itself and goes around the diameter, and you're done.
Mhm.
And so they even have a new one. Renishaw has a new one called a Revo, that is like, it just swoops like that, like out of a bore. It would just swoop and just pick it all. It's wild. Like, from a manual machine that I saw the first time, right, to what I'm seeing these systems doing is fascinating, right? And we're trying to stay caught up with that, so that I have a project in here right now that we're trying to interpret some dimensions, and I'm like, I have one CMM that can check this, and you guys have no CMM that can check this, because I have this PH20 head, and you guys don't have these rotations.
Hmm.
And so that is probably the biggest. The software, softwares are much better. They're much more user friendly. It's, instead of like traditional computer programming go-tos and all that kind of stuff, we're doing it by pictures almost. Like, we're doing, you want to get a diameter, click diameter, right? You don't have to say, hey, computer, we're going to make a diameter now, and we're going to do it like this, right? It's
Right.
diameter, how many points? Let's go do it. So
Yeah.
I think the ease of use, and that's good, because we need more programmers coming into this industry. And the easier it is, the more people who are going to be able to handle it and are going to be able to uh, grow and be better programmers in the long run,
Yeah.
I think.
That's cool. Next question is kind of similar, or maybe just the next step down the line. What are some of the emerging trends in your corner of the product development world, whether it be AI or other technology?
Yeah. So I think from the inspection side, it's pretty soup and nuts, right? It's pretty boring. Like, from our side. I think white light scanning and blue light scanning and shape grabbers and X-ray machines and all these machines that, I mean, this also is this last question too a little bit. All these systems where you can just put a product in and reverse engineer it into a model that you can manipulate and change into what you want it to be is fascinating, right? Like it almost, I want to stop short of saying it's easy to steal other people's products and design them, right? But we know there's people in other countries doing that, right?
Oh, yeah.
Like,
Yeah.
you know, and that's how they're doing it. They're scanning these things, and then all of a sudden you have a model. Like it's fascinating to me, especially as not being an engineer, that you know those scanners are getting more and more accurate, and they're getting really good. And you know, for surface, they are great. They're great, and you can, man, some of these X-ray machines, you can put a cell phone in there, and it gets everything in the phone. Like it reverse engineers the whole thing. You have a model for everything that you can just start pulling out. It's for people who know what they're doing with those. It's amazing. Between that and 3D printing, right? 3D printing, we're seeing parts show up that are 3D printed,
Oh,
right?
really?
Like absolutely 3D printed, and then a little machining done to them. We're inspecting parts like that. I mean, that's a big deal for manufacturing.
Sure.
Right?
Plastic
Like,
and metal?
plastic and metal. I mean, we're seeing more metal than plastic.
Sure.
Which, I mean, that's a whole nother ball of worms, right? Like the expense of 3D printers is insane.
Yeah.
But like,
yeah.
we have some 3D printed titanium medical implants in here right now,
Mm-hmm.
and they are wild. Like the surfaces you can put on them, and like for tissue to bind to, and all of this, and then they machine just a little bit off of it, and you're getting away from needing, you know, real manufacturing expertise, right? Now you just need some real design expertise and a really expensive metal 3D printer. And all of a sudden you have parts, right? Like you don't have the guys from manufacturing coming and being like, "Hey, Troy, we can't make this part. What are you doing?" Right? These so complex, we can't mill this, we can't machine this. Like, I just push a button and it'll be out in 2 hours, and it'll be right over there. And I just need you to machine the mating surface.
Yeah.
I mean, that's wild, right?
Yeah.
Like, I'm sure, especially from your point of view, that's super wild, right?
Oh, yeah. Yeah. It's very interesting to see what's happening in that area of our world.
Yeah. Yeah. Next is them 3D printing tissue, right? Human tissue.
Mm-hmm. Yeah.
Like you're going to see valves and all of that kind of stuff 3D printed. And that's going to be scary.
Yeah.
Scary but cool, right? Scary but
cool.
Right.
Yeah, like you said, you're no longer limited by manufacturing processes, or I guess the 3D printer is the manufacturing process. So.
I mean, you design it, you can build, you design it, you can prototype it, right? Like, there's not much these 3D printers can't do. You know, they may not have the surface you want, and they may not have the accuracy you want, but you can take a look at it and you can hand it to somebody on the manufacturing floor and say, "Make this." Right. And they look at it and be like, "Nope, go buy that $1 million titanium printer." Right. That you can print out 10 of them at a time if you want, you know, like that's fascinating to me. Like, I'd love to have one of those. So if you want to get me one for Christmas, that'd be awesome.
All right. I'll put you on the list.
Okay, cool.
Is there anything else you want to mention before we finish up?
Man, no, I mean, I feel like I talked a lot. People tell me I don't know when to stop sometimes. No, I mean, I think we covered most of what this industry looks like. You know, it's very niche. Like, there's not a ton of labs like us around. And we take that pretty serious, you know, that there's not, you know, if there's not a ton of places to go to get something, you need that place to take it serious and be fully invested in it. So we do that. Yeah, I think, you know, it's something I believe in. It's something that my team believes in, the importance of good data. especially for the end user. You know, when you're talking medical device, you're talking about a patient. At the end of the day, you're talking about a human being with a piece of metal or a piece of plastic inside of them, hopefully metal, that needs to be right. You know, I have some friends who are getting older and having knee replacements and hip replacements, and you know, I'd feel a certain way if something I inspected went awry for them. You know, so
Right.
we take it serious, and we know there's a lot of people out there that do, and so we're good. We're good partners for those kind of people.
Awesome. Where can folks learn about your company, and where can they find out about what was it, in the shop videos or?
Yeah. So the easiest place is www.wjtitan.com. There's links in there for a lot of what we do. There's a link in there to our YouTube page. Our WJ Titan YouTube page has at least 50 videos now called the In the Lab series. It talks about all kinds of GDT and 3D printing. And, you know, we don't have a huge product that we do, but there's a lot of intricacies of what we do. So, like I said, I think there's at least 50 videos up there. More every 2 weeks, there's at least 2 videos rolling out. So people can find us there. Website's always the best. Great way to contact us if you need anything. LinkedIn page, Instagram page. They all say the same thing. So website's usually the best.
All right. Awesome. I'll make sure I put that in the show notes.
Cool.
I really appreciate you doing this, Jim.
No, I appreciate you having me.
Yeah.
I'll always remember the first podcast I was on. It's this.
Well, I appreciate
it's this one right now.
Awesome. Thank you. I appreciate you doing it.
You bet. Thank you.
To learn more about Impulse and how we might be able to help you, visit impulseproductdevelopment.com.